Okay, so I have the effects of fructose metabolism. Okay, so before we start, I want to look at the difference between glucose and fructose. So glucose, when you first eat it, the breakdown of it is really regulated. There's a lot of feedback mechanisms. When it first goes into the bloodstream, it goes to a lot of places before it actually ends up at the liver to go to fat. So like the skeletal muscles take it in, use it for muscle glycogen. The brain is a big source of using glucose, and it uses that for energy, and a lot of other places use glucose as it goes through the bloodstream. And so glucose is used like for like immediate fuel production, right away. It can be burned, or it can be turned into fat and then have it stored for later. So our fructose, though, it is unregulated. There's no feedback mechanisms like there are for the glucose when it gets broken down. Another difference is fructose doesn't go to like the muscles or the brain or anything. So when it first goes into the blood, the body doesn't know what to do with it. So it just goes through the blood and it goes nowhere and then just goes straight to the liver. And then the fructose, instead of being used as an immediate fuel source, it's used for fuel storage. Okay, so I'm going to talk about fructose breakdown here. Like, what does that look like? So fructose with fructokinase does this. So in a normal cycle, ADP would be recycled back to ATP. However, when fructokinase is present because of the fructose, then this ADP is broken down to AMP. And so what happens to this AMP here is, like I said, it isn't recycled. It actually goes through a bunch of steps and it breaks down into uric acid. So with fructose, it switches the body into this use of energy. And this is going to make a little more sense in a second, like the evolutionary pathway. So way back when people were like hunter-gatherers or foraging for food and stuff like that, we had this evolutionary pathway that is triggered by fructose. So it's activated by fructose, and it promotes fuel storage. And this happens when it's either like as a response to dietary fructose, like a high increase of that, or as a response to like danger or a threat. So not just like a low level threat, but like way back when you're like, oh, I'm starving or I'm dehydrated. There's a flood. There's a famine. There's a drought. Like big life-threatening things for the body. So this triggers a pathway that allows the body to adapt to those things because of fructose. Nowadays, because of the way that fructose is handled by the body, because our diet has changed in adding so much fructose, it causes the pathway to overregulate and causes a lot of the good things that we wanted to happen if it was a threatful situation can become bad and negative now. So I'm going to show you that. So first we have, First we have fat storage. So I'm going to put that right here, fat storage. So fat storage is really important because it allows people to obviously use this for later. Next thing that we have, insulin resistance. Now we hear this as a buzzword and we're like, oh no, insulin resistance, that's bad, but that actually allows, in this context of this trauma, it allows the body to have an immediate source of fuel for the brain because the receptors are being resistant, and so the sugar doesn't go into the body, it just goes through the brain there. And so that allows that to happen. We also have glycolysis. So this also allows the body to immediately have a way to burn energy really fast. So it's just immediately burning that glucose as soon as it comes in. And so the fructose causes this pathway. Another thing that it causes increases blood pressure and salt retention. So this is important if they are in like a drought state, or like they're dehydrated. It allows them to fluid balance a little bit more. And then a final thing that this pathway triggers is foraging. So this is like going out and being able to eat a lot of food like really fast. So going out and just eating a whole bunch of food, which is good if it's like an animal preparing for hibernation. So looking at it like this isn't bad things. But now when we're having an increase in dietary fructose, it's causing an overregulation of this pathway, especially since none of us are actually in these like life-threatening situations. So what do all these things go to? So we have our fat storage here. Let me adjust my Our fat storage is obviously, if we keep storing fat and we're not actually ever getting to use it, it's going to lead to obesity. And then insulin resistance, type 2 diabetes, and glycolysis. So actually glycolysis is okay when it's like a short amount of time doing this, like in a trauma, but if we're living our whole lives in this state because of how much fructose we're consuming and this pathway is being triggered and always triggered and we're living in this state, this is actually the fuel source for cancer. So this is how cancer grows, is because of living in glycolysis. High blood pressure and salt retention, if you're constantly living in that, it leads to heart attack or stroke. And then from this foraging and binging methods, that can actually lead to some mental disorders. So this is what happens with this evolutionary pathway when it all goes wrong, is all those things on the bottom. Instead of doing the things that we wanted it to do, it brings obesity, type 2 diabetes, cancer, heart attack, stroke, mental disorders. And so I listed one on here, it says Alzheimer's. I'm gonna dive deeper into that for a second here. So like we talked about, the fructose putting that fuel conservation pathway, it stops having all the energy available and it's storing it. It doesn't have it available for use. This also does this in the brain. And so the brain cells actually don't have as much energy available for them to use. And if you're constantly living this pathway because of the constant intake of high fructose, then this can lead to Alzheimer's, as some recent research has been showing.